popped up. Now we're going to transition over to Devin with A2AI, who's going to talk about LLMs and using open source. Devin's going to be also helping with a panel at the R and Pharma Summit in Atlanta coming up in September. So looking forward to that. Devin, the screen is yours.
All right. Thanks, Phil. So hello, everyone. Good morning, good afternoon, good evening. I'm going to be talking about kind of the evolution a little bit of how AI has been used within our organization and within some of the groups that we work with. I kind of titled this Agents and MCP and RAG, which are all kind of terminology that's used in the ecosystem. And my hope is that by the time we finish this talk, you'll have some degree of familiarity, maybe inspiration, as well as some understanding of some of the kind of benefits and risks that we're kind of trying to work through as all of these different approaches to how to use GenAI are kind of percolating through the industry. So let's see if I can get my progress. There we go. Okay, so I'm the Chief Technology and Product Officer at A2AI. For those that have not heard of us, we are kind of a hybrid consultancy company. We have we're about 100 people. We have kind of clinical pharmacology and pharmacometrics and clinical groups. We're doing a lot of non-clinical and clinical development. We're doing submissions to agencies. So we're doing a lot of kind of work that falls under that clinical umbrella, the GXP compliant umbrella. And the technology group both supports our internal scientists, as well as we do both services work and develop products like our kind of compliant cloud kind of scale out platform. And so there's a lot of kind of use cases for both technology and science that are infused throughout our organization. But ultimately, much of the work that we're doing is still something that has a degree of sensitivity such that we see that there are a lot of opportunities for AI, but we have to do so very carefully. And I think this is the boat that most of us tuning in today are in. And so when we want to talk about these AI applications and how we might use them and what some of the trade-offs are, risk is a huge component of what we're dealing with. And so to think about risk, we really have to understand how that works, how these kind of applications work. And I want to breeze through this part of the talk pretty quickly. I think Emily did a fantastic job of setting up a lot of the concepts, and so I don't need to spend too much time, but it is important that we really do think about what fundamentally the interaction between the user, the large language model, and the application are. And so in particular, if at its most simple, the anatomy of an AI application, whether it's a command line tool or a chatbot or otherwise, is you have some application that's going to collect some information from the user. It's also going to have some other information that is usually kind of given by somebody who has either built the application or has some other knowledge around how they want to direct the large language model. There could be some external data that is aggregated on the fly based on what the user is asking to be done. And ultimately, that stuff is going to be bundled up and passed into the large language model. Now, one of the things that when we interact with folks that are trying to wrap their heads around GenAI is, they'll colloquially use concepts like they'll say like, well, when will the LLM learn how to do this? Or when will it remember this? And fundamentally, we have to remember that a large language model does not have a concept of memory. It does not have a concept of state or anything like that. It is a one-shot, you feed in information, it gives an output. And so everything around the interaction with a large language model over time is done at the application level in some way, shape, or form. So with that in mind, for one piece, that these things have, no long-term or even really short-term knowledge, they're really just one-shot, kind of question and answer machines. The amount of information you can put in there is super important to understand. And this information that we can put in there is referred to as a context window. And this is an area that a lot of the early AI work had to work around, because the context window is fixed. It's kind of an immutable law of whatever the particular model that you're working with has, and everything must fit into it. So as kind of Emily introduced, as other speakers have been talking to, this includes instructions, this includes maybe extra information, as well as your question. And one of the things that has made developing these applications easier and easier is this context window is expanding. A couple of years ago, it was 16, 20,000 tokens, and then it was 100,000, and it was now 200,000, and some models are even getting up to 1 million tokens. So more and more information is able to be kind of put into a single shot. Now, the thing is when you start having a conversation, when you start kind of interacting with this in a way that you might have a lot of information, you have to stay within this context window. And so if we use a chat style example, at the point in time that you actually bleed out of this context window because of saying, your question kind of extends beyond it, or the information that is kind of being pulled in is going to go outside of that, you can't do this. And so in such a case, like on this right side, something would need to be done in order to actually shrink this into the context window by either excluding certain information or summarizing certain information so you can actually get what you need. And this is one of the causes of kind of confusion and sometimes frustration around interacting with these AIs, where if you interact with a period of time, suddenly some of the conversations can become circuitous. And again, the reason behind that can be that a lot of times the reason that happens is because the information that you originally started with, that you still as a human have in your brain, has been lost from that context window, or sometimes even more dangerously, it has been over summarized to lose some of the specificity of the intent, and suddenly the LLM itself is operating on kind of distorted information as you're having a conversation. And so we have to think about LLMs consistently around this idea that they are instruction following engines, they have short-term memory. And so our goal with whatever kind of tool that we're building or product that we're integrating is to, whenever we interact with the LLM, give it precise instructions and the right information at the right time. And so what we wanted to do as an organization is to use this AI judiciously. And so we said, let's find some high impact themes across the organization that we wanted to focus on. And so we kind of bucketed these in 3 different areas. Kind of organizational process, best practices, meeting notes, things that are kind of slightly open-ended where we don't exactly know what the user might ask. And there's some kind of corpus of knowledge around what you might want to do. Then we have the kind of code review and QC and release notes. These are the areas that are heavily involved by our data analysts or our software engineers, where they are generally interacting with code, whether that be kind of engineering related code in other languages or kind of data science style code in R or Python. These are both a user group that is more technically inclined, as well as a lot of the kind of questions or needs are more focused in what they're trying to get out of the interaction with the LLM. And then finally, technical writing is a big area that I think everyone's interested in, whether it be clinical study reports or otherwise, of how can we improve the efficiency and the quality of that writing. And that has a whole other set of challenges that we can work through. And so to address these needs across the organization, we've been building different types of interfaces. We have a chatbot, we have a CLI, and we have some custom applications. And I want to kind of go through all of these and the trade-offs that we've been finding with them. So let's start with the chatbot. The chatbot is something that I think a lot of organizations have been experimenting with, particularly with both R and Python, Shiny plugins and otherwise that make this pretty easy to get started with. And the chatbot can have a very nice fluent interface for users to interact with. So for our chatbot, what we wanted to do is we recognized that trying to give a generic chat interface that anybody can ask any type of question was going to be very challenging to both maintain all the possible information you might need to answer in that kind of context window that I mentioned earlier, and that it can be difficult from an application perspective to figure out what the relevant context is. And so we decided to make that kind of somewhat of a non-goal and instead put a little bit of a shared responsibility on the user and broach the concept of experts. And so the idea of experts are, these are just different prompts with sometimes access to different data, but they're tuned to do different things. And so we had some kind of experts, if you will, that were more general, that had general capabilities, could answer general questions, and had general guidance in the kind of back end prompt that we were kind of retaining alongside the user query. Some examples that you can kind of see here that have built up over time is, giving some instructions to the large language model around how it should act, but also refining like how it's going to give recommendations. So for example, we would see it constantly recommending if you needed to open up a file, it recommending to use something like Vim from the command line. And so we started to infuse a lot of this with our own organizational preferences, like don't use a CLI, open it up with RStudio, or here's how our paths are structured on our compute cluster. So, don't recommend some path that is non-existent. This is the path that you can kind of expect. We also found it very helpful to not try to make the chatbot be able to answer everything, rather really put a number of guardrails and guidance towards it to say, do what you can, but also encourage help seeking if this is a question that the LLM itself cannot answer, and generally to encourage the user not to overly rely on its outputs unless they're able to kind of get a clear output reasonably quickly. We also had more targeted kind of prompts and guidance for more specific activities like code review and QC, where you could put this in the chatbot and people could copy paste code. But as I'll talk about in a little bit, that wasn't really the best interface and didn't give us access to all the things that we wanted. And so most of the chatbot related prompts were built around these kind of open-ended activities. And the finding that we had was that users took to it pretty quickly. They started interacting with it. And overall, it's been a big success within our organization with respect to us being able to infuse a lot of institutional knowledge that would often sit in static documentation, that people would struggle to find the bits and bobs and kind of synthesize them together. And for us, this was particularly tricky because over the lifetime of our organization, projects would start at different points in time where they had kind of different processes we might be following or different setup instructions. And so even small things like when you're dropping into a project that might have been started at a different point in time, what should you do? How should you do it? Is something that users didn't have to kind of self-service figure out from, scouring Confluence pages. They could go to the chatbot. Now, while doing this, one of the key things was that we also developed a dashboard alongside of it, such that all of the interactions that users had were also logged here, where users not only could we kind of track what they were asking, what the responses were, but also gave the users a number of places where they could, thumbs up or thumbs down or provide commentary around how helpful the response was. And so part of our overarching kind of organizational governance was around monitoring what the users were kind of doing to not like make sure that they were doing what we wanted to, but rather to kind of witness organically what they were trying to get help with, and then feed that back into making sure that the prompts and the information there was actually able to accurately address this. And to do this, this is where we were able to tap into the kind of more senior folks in our organization, where we actually have kind of regular reviews over the conversations people are having. So even if they've marked it as helpful or not helpful, having more experienced people in the organization review and say, what did they do? How did they do it? Is the response right? Has been instrumental in making sure that we could refine these over time to give a kind of good experience to the users, to make sure that there's accurate information, and importantly, also find areas that we could see the chatbot in the early days start to kind of lead people astray a little bit, where we could kind of put more guardrails and constraints to make sure that it didn't give them recommendations that were kind of dangerous or otherwise not something that they should be running without feedback. And so the chatbot has been great for us as an organization for a number of things. But when it comes to code itself, there's things that you want in a code base that aren't necessarily amenable to copying and pasting easily. Not only the code, but some other surrounding context, where we also decided to build a CLI tool. We've kind of tentatively called it LLM diff. At this point in time, that name doesn't completely make sense for all of its capabilities. But the goal of LLM diff was ultimately to lower friction for our users. We didn't want them to need to kind of memorize tons of different commands in order to kind of do things in the analytical environment. We didn't want them to have to remember too many commands when it came to being able to accumulate the context needed in order to kind of get good information back from the LLM. And so we built this tool that helps them accumulate the information needed to get some outcome. You know, I want a code review. I want this to be QC'd via a very specific checklist. I want to generate kind of notes about something. You need to be able to aggregate the information you need for the LLM to guide it into giving you a reasonable response. And so this tool provided kind of a gateway to be able to do this easily. And we wanted to do this in a way that people could understand what was going on. And so I'm gonna hit play on the video real quick right here. So this idea here is, this is an example of a QC where we have a checklist of things that we wanna make sure that people do. You know, don't use read.csv, use read_csv or data table, make sure you have a session info. But there's also some areas that are not just kind of like code, you know, use this function, but are a little bit more nuanced, like, you know, make sure that paths are structured a specific way, and that anything that might refer to a path that isn't just a kind of string path, but something built up with tools like here actually accurately reflects what is on the file system. And so you can actually see here that this command on line 48, fd type dir, is going to run another command as it's kind of accumulating this information needed to actually be able to provide more context to the LLM when it does the review. And so we have an R script here that's kind of representative. And if you asked it for a code review as a human, you'd kind of have to squint and stare at that checklist for a bit. And this is where the large language models have been fantastic around being able to review very quickly and provide this feedback, where we don't have to wait for another human to QC this or provide feedback. You can get this iterative review very rapidly. And it's actually going to pick up on some pretty good stuff. So you can see here, you know, it found the low-hanging fruit, like no session info was present. But it also was able to pick up subtle things, like there was a kind of typo in line 13 here, script. Well, the directory was actually scripts, not script. It found that, it figured it out, that was a directory invocation, and it provided a recommendation of what to do. This is something that we are kind of rolling out aggressively to help our scientists be able to figure out what they are, you know, better practices without needing to go to another human immediately. It doesn't mean we're replacing human QC, but it means that by the time a human is QCing it, a bunch of the low-hanging fruit that a computer is very good at is able to handle that, has already kind of gone through that pass. For the sake of time, I want to kind of jump forward a little bit further. You know, there's some other toolkit components of this CLI that have been very helpful for figuring out you know, how to effectively interact with an LLM, particularly in larger projects that use a lot of tokens where you have that limited window to work with. But I want to kind of hopefully close out with this custom application. I think this is another area where it's a very differentiated use of AI, where we're actually not having users interact with the AI directly, rather the AI is upstream in a pipeline. And so in this case, We're starting to use the AI to review medical texts or help with translations or other pieces of these kind of highly sensitive reports where it's very important to get things right. And we've been able to develop a number of prompts that focus on different areas of everything from, the way that units are written to laboratory values to key medical terms, where it's able to provide a review of the information. And the key thing here is to call out that it's a review. It's not, we're not just having the AI generate all of these things. We're actually using it judiciously to make sure that it can actually provide feedback, where we have these dashboards that allow our human users to go review that type of stuff very quickly. So you can get a report, you can go in, you can see the findings kind of prioritized by criticality, where again, that criticality is assessed by the AI based on some kind of patterns that we've given it information on how to grade. And then you can investigate. That investigation allows us to then drill in. And this is where the synergy between the direct use of AI as kind of a tool that augments a single person versus AI as a part of a broader technological landscape has been something that has been very fruitful for the organization. And so I'd encourage you all to not just think in terms of kind of tools directly for you, but to think about if there's possibilities to apply in these broader use cases where you're still going to need to use the same kind of concepts around prompt management and specificity and managing the context windows, but can really have a differentiated impact. Trying to be conscientious of time, so Phil or Harvey cut me off if at the time needed, but the last piece that I wanted to go through was the concept of, these examples that I showed were all, we'll call them relatively simplistic from an AI perspective around, they are collecting some information, sending it into the large language model and getting some outputs in that single shot. When we think about agentic AI, the biggest differentiator is that now what is going to happen for an agentic application is that the large language model and the application are going to sit in a loop, where the large language model is going to be presented not only the question, but the tools it has at its disposal to try to answer that question. And then it can make a decision around whether it can answer the question or if it needs to go get more information in order to kind of achieve its objective. And so there are kind of simple cases that can be used, like tool calls, where you might want to get more dynamic information, to much more complicated cases where you actually want the LLM to give instructions to the application to invoke on its behalf. And that's where you see things like Claude Code and these other kind of agents where they're actually kind of writing code and putting that on the file system and executing it, really are around this loop where the LLM is going to be giving instructions for some arbitrary period of time, and the application is going to be executing those. And so we ourselves have been experimenting with this. We've added things like tool calling to our chat app, where the users can start to ask a new class of questions. What is the latest thing? Where that latest thing is something that is dynamic, that the LLM can recognize and say, oh, I can make this API query. I can go get some more information and then give you a better answer, something that doesn't have to be kind of hard coded in. And looking forward, I think this is the big area of active investment and kind of research and figuring out how to find the appropriate boundaries for, where can you use simple things like simple tool calls? Where do you need full-blown agents? And when you're using agents like Claude Code or otherwise, how do you make sure that they can, sit in that loop and do safe activities without going too wild? We recognize that there are a whole bunch of different kind of agentic tools emerging over time, and these things all have different behaviors around how they act as an agent, what they have access to, how they determine their stopping criteria. So it's a non-trivial problem to find, to kind of figure out. And so our approach has been to think of it in terms of invest in developing composable solutions that you can kind of weave together with these emergent capabilities that are existing in the broader ecosystem. So, don't try to build your own Claude code, rather recognize where you can hook into Claude Code or GitHub Copilot or Positron. Taking the time to figure out how to do that can enable you to experiment judiciously with AI to make sure that you can have the impact that you need in your organization without necessarily opening up too much of the floodgates of your kind of code ending up meandering off and trying to do things that you might not want it to. And so from a closing thoughts perspective, to kind of pull this together a little bit, across these use cases, if you are interacting with code and kind of coding agents directly, version control to me has become a table stakes activity to make sure that any of those kind of changes that the kind of agentic things are making are something that you as a human can review. Provide a toolbox of tools. I think we're too early in the kind of landscape of all these different tools that are emerging, some that are kind of built in-house, some that you're kind of pulling in like Positron. Don't try to find one tool to rule them all at the moment. Instead, a toolbox that can kind of control the trade-offs and monitor how those tools are being used and the impact that they're having to figure out the direction that you want to continue to go as an organization. You can use these agents, but be conscientious of their pros and cons, particularly their ability to really do some wild things that you might not expect a human to do. And so as you're starting to use them, find projects where you can learn how they operate that are lower risk, but don't shy away. Like, use them, learn about them, figure out how to adopt them. There's no kind of silver bullet. It is absolutely something that you can learn to operate as an organization, but you need to get kind of reps within the organization to figure that out. And finally, I suggest to scale your focus as you're developing these AI applications based on what I'll call the durability of what you're working on and the utility. So, the specific tools themselves will be replaced over time. They will come and go. There's going to be the kind of flavor of the week of a lot of these different kind of tools that are going to change rapidly. But there are portions of what it takes to get an AI application into production, the data being acquired and normalized, evals, which are critical to being able to test an AI application to make sure that it kind of works and continues to work over time. As you swap pieces of it. And overarching governance and kind of logging how users interact are so critical to being able to understand the impact of the various applications, that those are things that are going to transcend any of the kind of changes that are made at that kind of implementation layer. And so I think a lot of people are talking about the actual applications that they use, but the focus should likely be, once you've gotten through that initial hurdle of releasing a couple things or trying to release a couple things, that how you test them, how you govern them should become a critical part of the conversation of how to build an AI product that makes it into production, that stays in production, that evolves over time in production. And if you do that, you're going to be able to respond for the fact that ultimately these AI applications are changing so rapidly compared to so many other things in our organization, in our industry, that you can still be set up for success. You can still move quickly. You can still do this in GXP contexts. But you need to have everything, not just the application. Build towards being able to have those other pieces, and you can be successful.
All right.